Hello everybody, my name's Trevor and this is the walkthrough of the September SecDSM mini CTF. Just to jump right into it, if you attempted this, you probably saw this screen and noticed that we need to blow our way into the hatch, apparently. So first thing I tried obviously is to click this giant detonate button at the bottom, and it doesn't do anything. After trying to click this several times, I decided I'm going to take a look at the HTML of the page using inspect element. And first off, we'll see that just seems like a basic HTML page. I did first notice that there's some hatch numbers in the alternate text of the image. I thought those maybe would be helpful in the future, so I just made note of them. Then I also noticed there is a JS file included here at the bottom, main.js. So I went to go take a look at that, and first off, notice that this first class, explosive, has a function detonate that's very obviously obfuscated, right? You have some variable names that and function names that are named really weirdly. And then obviously it's called and says, why can't we get in? First, when I see obfuscated code like this, I want to try to de-obfuscate it before I try to jump into it. There's lots of deobfuscators and obfuscators online that we can use. I just searched up JavaScript Deobfuscator, and the first one actually linked to this, copied and pasted the file in here, and you can see when you run deobfuscate on it, you get a pretty clean output. Looking back, you can see there's a /station directory. It says that's where it goes to. However, if you actually see in the obfuscated code, there's a string that's /station. So you don't technically need to deobfuscate it to get that. However, it makes it a lot nicer to look at if you do. So obviously, when we see that, you're going to go check out that web page. So different web page, obviously some new images on here and some audio at the bottom. It's not a video, it's just audio. And I'm not going to play the audio, but due to copyright reasons, but there is an audible beeping sound every about 2 seconds. So I did make note of that. However, because we had to look at the HTML last time, first thing I did was inspect this page as well. And you can see another reference to numbers, and they're the same numbers. This time mentions a lottery ticket, last time was hatch numbers. And so definitely, I've seen this twice now, so this is definitely going to be important, so I kept note of it. And I'll get to that, what that means in a little bit. However, on this page you can see there's actually 2 links to song and eSong. I did check out both of them, but eSong is the one that's more interesting. I also noticed in this page that there is another main.js file, so thinking that there may be some hidden content or another page that we have to go to, I definitely wanted to check that one out. And you can see that there's just a link or just some text, no JavaScript or links or anything like that. Usually when I come across encoded or encrypted data, I usually like to put it into CyberChef, which is my kind of favorite go-to tool. So I copied and pasted that into the input of CyberChef, and just something that I have a feeling most of the time when I see spaces in a ciphertext like this, I usually try to do some basics ciphers on it. So the most basic cipher is the Caesar cipher or ROT13, and you can see here I put the recipe in and ran it against it. And you can see the output is obviously text, so there we go, we guessed right, and we have to go find apparently the Stegonaut. You can do some other things in CyberChef, like the magic function, to potentially find this. You might not get it right away. However, just prior knowledge got me to this point. But moving on from ROT13, we got to go check out Stegonaut. So I Googled Stegonaut and got to this page. And it says simple audio steganography, so I knew we were doing something with that MP3 file earlier. So I downloaded it and just uploaded it here to see what it would be, and I've already uploaded it, and I just have to click this extract button. So when I do that, we get some text out, and this is very obviously intentional. We're not just getting random data out because it starts with private key, begin OpenSSH private key. And so at this point, I'm realizing, yeah, we're gonna have to deal with something SSH-wise. You can see here we got the open, begin and close tags of this open SSH private key. So we're gonna have to SSH somewhere. And that was mentioned as being interactive in the start of the CTF. So first off, I wanted to check to see what was open on the ports because maybe we can just SSH and that's the next step. So going over here really quick to Kali. First thing I noticed was I deal with IP addresses. I'm not going to deal with DNS. You can if you want to, but it's just easier for me. So I ran a quick Nmap against that IP address that's open, and you'll see here that there is a large number of ports open. This is just a basic Nmap scan. I didn't do any special options on it, just ran against the IP address to see what was there quickly. And I won't go through all of the ports, but one that was notable was SSH was closed. So that kind of squashed the idea of just easily SSHing in and doing that. When I see a lot of ports open like this, it's usually something to do with like honeypot, or they're just phishing on the internet. So that was kind of interesting. But going back to the SSH, SSH key, I just kind of wrote this down, kept it off to the side because we're going to need it eventually, I think. So beyond that, I kind of just moved on. I did take a quick detour after I found this and I saw the ports. I wanted to make sure I wasn't missing anything. So I went back to some of the pages and took these images and did least bit significant bit steganography against them using the tools similar to this. You can use, there's ones for Kali or Linux. They didn't have anything inside them, just basic text. I did see one of the images did have the numbers also in it. So that again made those very strong that way. But other than that, there wasn't anything like port numbers that I needed to look at or something like that. Now at this point, seeing a large number of ports on the box in the Nmap scan, I thought there's probably something to do with those. So seeing those numbers earlier, I said, okay, what's on those ports that we see? So the first one was port 4. So if we go over to this other tab in Kali, and I tried netcat at first, and there's some web server running on it, so I just wget the site on port 4, and you see there's an index file. Now if you save that and cat it, you get just kind of looks like a random data out. Continuing on the theme, I said, okay, let's check the other ports that were in that list. So I checked port 8 next. Again, got random data. 15, 16, didn't have anything on it. So I didn't really worry about that too much. And then you see this data is completely different than the one we just got. 23, continuing on with the theme, and then 42. So after taking all these data out of this that looks somewhat random, going back to my friend CyberChef, and at first I did this individually per page, but I quickly learned after trying to poke around on port 3, because that is the first message right here. This is the first message. There wasn't anything there. And once I concatenated all the data together in order, you'll see the data makes more sense. You have a port number, a high port number, so that's good for us for SSH. JLock seems like a username to me, obviously because you have first initial and then last name. I'll take a quick tangent here to talk about the significance of that. I Googled the numbers at this point to see what was important because it was getting fairly interesting to me. If you ever watched the show Lost, you're probably screaming at your screen saying, why didn't you see this earlier? I didn't ever watch Lost. So it was kind of an eye-opening moment saying, oh yeah, there's a wiki about this and the numbers are very significant. JLock stands for John Locke, a person on the show, and you can see the last is knock first. So knock first to me says something to do with knocking on doors. So I've heard of the term port knocking. Some people have not, but port knocking is, I'll go back here to some information. There's a Wikipedia page about it that gives a pretty good kind of overview on it. And then the Arch Linux wiki page has some good information about just how to set up port knocking. I tried using Nmap to knock for a little bit, but then I quickly found that there's a knockd agent that you can install to manage this, and it comes with a command called knock that you can just specify an IP address and the port order you would like to knock in. So that was pretty handy. You can see here how it would be configured on the server and using just firewalls to restrict access. So knowing this, I'm probably going to have to port knock. What is the obvious order? Those numbers are very significant, so what are we going to check first? Let's go back to Kali here. And so first off, I said, okay, I'm going to try knocking on these ports. It didn't work right away. I had some failures in there. I tried knocking on all these ports in order first, knocking on everyone but 16, right? Because we had that issue with 16 that didn't come back. But in the end, I did find out that knocking on these ports in order is the solution. So we run this command, knock, tac-v is the host, and then the order. You'll see it just hits those over TCP. And then we can SSH with that SSH key and that one port 33347 using the JLock user. And you'll see here that we get a session. Just a quick note, follow this note up here. You don't need to do anything crazy on this box. No privilege escalation, breaking the system. You don't have to do any of that to solve this. I definitely followed that. I'm not going to break it for other people. The first command I ran when I got into here was ls, and I like to run my ls's with tac-la to show everything. And I noticed there's a lot of directories in here, and there's some other files because we're in a home directory. There's one file that's missing now because when I first noted it, it was the bash history file. This will almost kind of give away a little bit of it, but I was able to use some of the commands that were in there to see kind of the solution. But at this point, if you're not thinking of, hey, go to the directory of the numbers, that you're on the right track. So we're going to go check that out first. So I'm just going to actually cat a file. So we're going to check 4, 8, 15, 16, 23, 42. In this directory, there is a file called flag.txt. Now I could just cat this file out, but I will say if you were to just cat this out, it's going to be random data. So we're going to skip ahead a little bit and run strings against it, because this will show all the strings in this file. And you can see here, there's a bunch of random data. There's a few names thrown in there at the bottom and at the top. However, if we scroll up, just as I did, you can see about halfway through the file, there is a flag, right? That's the format of the flag. So there's the final flag that I submitted. And I will say you could also search for this flag using something like grep that just search through the files, but you don't absolutely need to, because my first thought, even without seeing the bash history and seeing all those numbers, was, okay, we need to go to the directory of the numbers that we saw because we've seen them so many times before. So that's pretty much the gist of it. There's not really anything else in this file other than a few names and references, but at the same time, it was a fun CTF to do, and I hope everybody thought this was interesting, and thank you to Austin for creating it.